Hello everyone, welcome back to the video lecture series of Electrical Circuits and Network. I hope you are doing well, and in the previous lectures we have discussed the source transformation technique. In this lecture we are going to discuss delta to star conversion technique to reduce the given circuit. Okay, so let's get started. First we will discuss what is star and delta network. Okay, suppose we have the three resistances, these three resistances, this R1, R2 and R3. This 1 and 1 dash, 2 and 2 dash are the terminals of that resistor. Okay, this is the R1, R2 and R3. Okay, when these three resistances whose 1 dash, 2 dash and 3 dash are connected together. Suppose one of the terminals of all the resistances are common. It may be like this also, or suppose we have the same resistances R1, R2 and R3. This 1, 1 dash, 2, 2 dash and 3, 3 dash. But here 1, 2 and 3 are connected together. In this manner also, when the network is shown, this network, these resistances are not connected in series also and not connected in parallel also. This combination is neither series nor parallel. Okay, then which type of connection is this? This type of connection is known as star connection. Okay, where one of the terminal of all the resistances are connected together. That is common. Okay, this is the common point for all the resistor. Okay, it can be drawn in this manner also or in this manner also. In this case also, this is the 1 dash point, this 2 and here 2 dash point, this 3 and 3 dash point are there. And 1 dash, 2 dash and 3 dash are connected to a common point. This type of network is known as star network or Y network. Okay, why Y? Because suppose we have drawn like this. Okay, we can also draw this network as this, where 1, 2 and this is the third branch. Then it resembles a letter Y. Okay, so it can also called as star network or Y network. Then what is delta network? Suppose we have these three resistances, same three resistors, R1, R2 and R3. Okay, this is 1, 1 dash point, this 2, 2 dash point, this is 3 and 3 dash point. And in this case, this 1 dash point is connected to 2, this 2 dash is connected to 3, okay, and this 3 dash is connected to 1. 1 dash is connected to 2, 2 dash, this is the 2 dash point, this is the 1 dash and it is 3 dash. This is the 1, 2 and 3 and 3 dash connected to 1. Then this network is also neither series nor parallel. We cannot say this R1, R2, R3 are series or parallel because they do not obey the series and parallel combination laws. Okay, so then this network is known as delta network. Delta network. Okay. Here the delta network normally shown with this diagram. This is the delta. This is the delta operator. Okay. So it resembles this delta symbol. So it is known as delta network. Here this will satisfy these conditions. All the conditions. Here 1 dash and 2 are connected. Here this is 1 and 1 dash is what? Here 1 dash. This 2, this 2 dash, this 3, 3 dash. Okay. 1 dash and 2 are connected. Here 1 dash and 2 are connected. Then 2 dash and 3 are connected. Here 2 dash and 3 are connected. Then 3 dash and 1 are connected. So here also 3 dash and 1 are connected. Okay. So we can draw in this manner also and or in this manner also. These are same and these are known as delta network. Okay, and according to the connection, the resistor name given as R12 is connected between terminal 1 and 2, so this is R12. This resistor is connected between 2 and 3, so R23, and this resistor is connected between 3 and 1, so R31. Okay, in this way we can label the diagram. Now let's see how to convert given delta to a star network. Okay, given delta to a star. This is the delta, given delta, whose values R12, R23 and R31 are given to us, and we have to convert this delta to star for reduce the complexity of the given network. Okay, for solving the given network, we want this delta to be transformed to its equivalent star. Okay, this is the delta network to be converted, and this is the equivalent star network we want. Okay, then we know the values of R12, R23 and R31 as this is the given delta. So we want R1 value, R2 value and R3 value, and how to find that is given by these expressions. This R1 can be calculated with the help of this expression, where R1 is equal to R12 into R31 divided by R12 plus R23 plus R31. This R1 is calculated in terms of these three resistances. Okay, this R1 is equal to R12 into R31 divided by R12 plus R23 plus R31. Okay, then how we will calculate R2? R2 will be calculated R12 into R23 divided by R12 plus R23 plus R31. Here denominator is the sum of all the resistances connected in delta. Okay, remember this. In the denominator, when we are converting this given delta to star, the denominator will be sum of all the resistances connected in delta, sum of the three resistances connected in delta, and in the numerator, where this is the R1 point, this is the one terminal. So which resistances are connected to one point? This R31 and R12. So R31 into R12. In this way we can remember this. Similarly, R3 will be R23 into R31 divided by R12 plus R23 plus R31. Okay. Using these expressions, we can find the R1, R2 and R3 values. Now, how to remember this? How to remember this trick? Here, when we want the given delta, this delta is given to us. Okay. This delta network is given to us, and we want the equivalent, its equivalent star. Okay, then how to remember? When we want star from delta, then draw that to be required star in the given delta with dotted line. This is the given, this is the delta given, and this is the star to be that we want. We want this star network, and this is the given delta. This is the given delta we have, and we have this R31, R12 and R23 values. Then this star should be with dotted lines. Okay, so we will not draw this, we will draw with dotted lines. Okay, now we want this R1, R2 and R3 value. Then remember that when we are converting given delta to a star, then always remember that denominator will be sum of all. So right here denominator R is equal to R12 plus R23 plus R31. It is simply sum. Okay, it is sum of the three resistances which are connected in delta, which are connected in given delta. Okay, then we want this R1, R2 and R3 value. Then how will we remember this? This R1 connected where? Here at this point. Then the product will be of this R31 and R12, because these R2 are common to this point. So R12 into R31 divided by R. Here, suppose we want to calculate this R2, then what will be the product? R12 and R23, because they are connected here. When we want R3, R3 is connected here, so R31 and R23 will be multiplied. Okay, in this way we can remember this. Also, here, observe here, R1 is there, 1 is suffix here. So, what are the resistances which have 1 suffix? Multiply that. Here R1 is there, okay. So, multiplication will be R12 and R31, because 1 is here, 1 is here, and divided by sum of all. Here R2 we want, so here suffix R2 is there, suffix R2 is there, suffix R2 is there, so this will be the product. Okay. Now, when we want R3, then this suffix R3 is there and this suffix R3 is there. So, product of that two which have the same suffix and divided by sum of all. In this way we can calculate. In this way we can remember. Now, let's solve some numericals based on that. Here question is draw equivalent star connection. We have given this delta network and we have to convert it to a star network. First we will draw this. We want this network. Suppose these are the 1, 2, 3 terminals, then this also 1, 2 and 3 terminals. We want these values. Observe here, given delta have all the resistances are identical. All the resistances are identical. Here R12 is this R12, this R23 and this R31. Okay, and all are same. R23 equals to R31 equals to 10 ohm. Then R1, R2 and R3, R1, R2 and R3 will be same also, because this is the equivalent star of given delta. These are identical, so this also identical. So let's calculate. We know R1 is here, so drawing dotted. R1 is here, R1, this is R2 and this is R3. So R1 we want, so product of these two which are connected at 1, so 10 into 10 divided by sum of all. Sum of all is 10 plus 10 plus 10. 10 plus 10 plus 10 will be 100 divided by 30 is nothing but 10 by 3, which is equal to 3.33 ohm. Okay, this will be the required answer. In this manner we can convert the given delta to its equivalent star. Let's take another example. Here we have this delta network where these are 6 ohm, 4 ohm and 2 ohm. Let's label it 1, this terminal 1, this is 2 terminals and this is 3 terminals suppose, and we want the equivalent star. Okay, so this 1, 2 and 3 terminals, and this is the common between them. So this will be the R1, this R2 and this will be the R3, because these are the 1, 2 and 3 respectively. This R1, this R2 and this is R3. Okay, we want R1, R2 and R3 values. So first what we will do, we will draw equivalent star that we want inside the given delta, and this will be the R1, this will be the R2 and this will be the R3, and this is what R12, R23 and R31. Okay, now let's calculate it one by one. The required R1 will be, R1 is connected to this point R1, So one suffix is common to R12 and R31. So product will be R12 into R31 divided by sum of all. First we will calculate here sum of all. R sum is equal to R12 plus R23 and R31 is nothing but 6 plus 2 plus 4 is 12 ohm. Okay, so right here R sum is equal to R12 is what? 6 into R31 is 4 divided by R sum is 12 is nothing but 2 ohm. So value of R1 is 2 ohm. Similarly, R2 is equal to R2 is common for R23 into R12 divided by R sum. The value of R23 is 2 into R12 is 6 divided by R sum is 12. So this 12 by 12, 1 ohm. Similarly, this R3 will be again R31 into R23 because 3 is common for these two divided by R sum is equal to R31 is 4 ohm into R23 is 2 divided by 12. So this will be the 2 by 3 ohm. So these are the required values of R1, R2 and R3, that is the resistances which are connected in equivalent delta that we want. Okay. So let's take another example. Here the question is, draw equivalent star resistances are given for the given network shown below. Okay. This is the inner delta 8 ohm, 16 ohm, 8 ohm. But this 16 ohm is connected here in between these 2 points. Suppose mark this point 1, this is 2, this will be 3. So this will be 1, this will be 3, so this will be the 2. So this 16 ohm are connected between 1 and 2 and this 16 ohm also connected between 1 and 2. So this 16 and 16 are in parallel. They are connected in parallel. So first we will calculate its equivalent. 16 into 16 divided by 16 plus 16. Okay, this 16 into 16 divided by this 32 and this will be 8 ohm. Okay, now this will be converted to a single resistor. This 8 ohm, these are the 1, 2 and 3 point. This is between 1 and 3, 8 ohm, this 2 and 3, 8 ohm and 1 and 2 also. 16 connected in parallel with 16 will be 8 ohm. So this will be the also 8 ohm. And we want the equivalent, its equivalent. Now this is the delta network. This is a delta, but this is the delta, and to which one branch is connected in parallel. Okay. Now convert this delta to star. As these R3 are same, so its equivalent network R1, R2, R3 will be equivalent network is this. R1, R2 and R3. This will be also same. This R1, R2 and R3 values are same. So let's calculate. As the R1, when we draw this R1, it will be here. R1 because it is connected to 1. So R1 is connected to this and this. So 8 into 8 divided by sum of all, this 8 by 8. 8 into 8. Okay, so it will be the 8 by 3. 8 by 3 ohm. So value of R1, R2 and R3 will be 8 by 3. Okay. In this way we can convert the given delta network to its equivalent star network. Remember here one trick is that when all the resistances are same in given delta, then its equivalent star will be, suppose we want Ry is the Ry we want this Ry. Let's change this color. This Ry and this is R delta. Suppose we have given this R delta, that means the value of R connected in delta, then the value of R connected in its equivalent star will be R delta divided by 3. Remember this. But the condition is that when all R have same value, when all the resistances are identical, in that case only its equivalent star value will be its divided by 3, R divided by 3. Here, so apply this to here this 8, 8, 8 are same, so its equivalent resistor in star will be that resistor divided by 3. See here, that resistor divided by 3. So no need to calculate, directly we can identify this. Okay. See also here the resistances are different, so values are different, and in this case the resistances are identical. These resistances are identical. These resistances are identical, so its R value will be R star will be R delta divided by 3. And what is the value of R delta? R delta is 10 and divided by 3, 10 by 3. See here, 10 by 3. Okay. So by using this trick, you can directly write this value, required value. Okay. Remember this. So this is all about how to convert delta into its equivalent star. In the next session we will discuss how to convert given star into delta. So for that, stay tuned and keep learning. Thank you.